Hello chemists, this is a Bales chemistry walkthrough video for calculating the pH after a weak acid has reacted with a strong base. This is an example where there's an excess of acid left over, and we've done another video where there's a link at the top of the screen now for an example where there's an excess of base left over after the reaction. So in this calculation we're going to go through several steps, the first of which is we're going to work out the moles of acid and the moles of base present and work out the excess. We're then going to work out the moles of acid and A- which are left in the solution after the chemical reaction. We're then going to use the equation concentration equals number of moles divided by volume, remembering that the volume has now changed because we've added an acid and a base together, so we'll now have new concentrations of acid and A- after the reaction. We'll then use the Ka expression, here it is in its rearranged form, to work out a value for H+. And finally we'll put that value in there with minus log hydrogen ion concentration to work out a value for pH. Okay, so we've got 50 centimetres cubed of a 0.5 mole per decimetre cubed solution of methanoic acid, which has got a Ka of 1.8 times 10 to the minus 4. It's going to be reacted with 20 centimetres cubed of 1 mole per decimetre cubed solution of sodium hydroxide, and we're asked to calculate the pH of the remaining solution. So this is very similar to the ones we've looked at in the example before, and we've looked at the steps we need to take to do it, so we're now going to go ahead and calculate the answer to this question. So first thing we're going to do is we're going to calculate the moles of HA. And to do that, we are going to do the 50 centimetres cubed divided by 1,000, and then we're going to multiply that by 0.5, which is its concentration, and that's going to give us a number of moles of 0.025. We're then going to work out the moles of OH- from the sodium hydroxide, and to do that we'll take the 20 centimetres cubed of sodium hydroxide, we'll divide that by 1,000, and then we'll multiply that by its concentration of 1, and that gives us a value of 0.02. Once we've got this step, we need to work out which one's in excess, and now just by quickly looking at it you can clearly see that there are more moles of HA than there are moles of sodium hydroxide, and methanoic acid and sodium hydroxide react on a 1-to-1 ratio. So we'll just make a note here that the moles of acid are in excess, and then we'll just quickly calculate what that exactly is. So we'll do 0.025 for the moles of acid, and we'll minus 0.02 for the moles of hydroxide to be left with 5 times 10 to the minus 3 moles of acid. Now we also need to know how much A- is formed. So the A- is formed by reaction with sodium hydroxide. So for every mole of sodium hydroxide we have here, we have a mole of A-. So as we've calculated, we have 0.02 moles of sodium hydroxide. So we have 0.02 moles of A-. We'll progress to the question. The next step we need to do is we need to turn this into concentrations. And to do the concentrations, we'll need to work out a volume. And to work out the volume, we're going to add the 50 centimetres cubed from the methanoic acid to the 20 centimetres cubed of sodium hydroxide. And we're going to divide that by 1,000 to have a volume here of 0.07 decimeters cubed. We can then work out the concentration of HA by taking the number of moles of HA, which was 5 times 10 to the minus 3. And we're going to divide that by 0.07 to get us a concentration of 0.071 moles per decimeter cubed. And then we'll work out the concentration of A-, and we'll take the number of moles of A- as 0.02. Remember, that's equivalent to the same number of moles of sodium hydroxide we started with, and we'll divide that by 0.07, and we'll get a 0.29 moles per decimeter cubed there. Once we've got those concentrations, we're now going to look at how we get a hydrogen ion concentration, and to do this we're going to use the Ka expression. Remember, Ka equals concentration of H+, concentration of A- divided by the concentration of HA, and we're going to rearrange that so we've got Ka multiplied by the concentration of HA divided by the concentration of A- to give us the concentration of H+. We'll put the numbers in that we've calculated from above. So we've got a Ka value of 1.8 times 10 to the minus 4. That's shown in our question. We're going to multiply that by our HA, which is 0.071. And we're going to divide that all by our A-, which is 0.29. And this will give us a hydrogen ion concentration of 4.40 times 10 to the minus 5. And the last step we need to do is we need to work out pH. And to do that, we're going to do minus log of hydrogen ion concentration. So that will be minus log 4.40 times 10 to the minus 5, which is going to equal 4.35. That's it for this walkthrough. There's a link in the description to the PDF file with all the workings on it. If you've enjoyed the video, make sure you hit the thumbs up below and check out some of our other videos on the playlist on the screen now. Thanks for watching.